Hello, this is Mr. McGovern, and welcome to the fifth video in the Energy and Work series, and this is about introducing the formula for energy. So we've spent quite a few videos introducing energy in terms of bar charts, and we're going to extend on that now by introducing some formula and showing an example of turning a bar chart into a formula. So the formula that we have for energy this year is we have one for kinetic energy, which you would have seen before, half times mass times velocity squared. One for gravitational potential energy, which is mass times gravity times height. It's sometimes written as EP and it's sometimes written as EG. Spring energy, which is also elastic energy, is sometimes written as ES, E spring, or EL, E elastic. And that's a half times K times X squared. Now, in the earlier video on springs, we introduced this value K, which is the spring constant, and X is the amount that's been compressed or the amount that's been extended. And we have a formula for work, which is work equals force times distance. So let's show an example of using those formula. So say I have a toy car and it's just rolling along on its own steam. It's a frictionless situation and it rolls up the hill. So as I've said earlier, I want to do my energy bar chart first. My system is the car, that ramp and the earth. It's moving to start with, so it's got kinetic energy and I've given it 5 bars. And when it gets up the hill to its highest point, it's not moving anymore. So 0 kinetic energy, but it's up high, so it has gravitational potential energy. And this bar chart allows me to write down a formula. An energy conversion equation, where I have kinetic energy equals my gravitational energy. So knowing that, how high does the car get? So I have kinetic energy as gravitational energy. I have a formula for kinetic energy, half times mass times velocity squared, and I just introduced the formula for gravitational energy, mass times gravity times height. Now I can put some numbers in for those. I know the mass is 4 kgs, so I can put that in. I know the speed or the velocity is 3 meters a second, so I can put that in as well. I know the gravitational field strength on Earth is 9.8, I can put that in. The only thing I'm missing is height, and that's what I want to find out. So when I simplify that, the left hand simplifies to 18 joules because it's an energy. The right hand, I've got 4 times 9.8, that's 39.2 times H. Then I divide both sides by 39.2 and I'm left with H is 0.46 meters. So, as a summary, start with your energy bar chart. I know it seemed really easy in this question here, but you will get harder and harder questions that have more than 2 types of energies. This one here just had kinetic energy equal to gravitational energy, but when you get into situations where there's more than 2 types of energy, a bar chart really helps you out. Even me with all my physics degrees, there's some situations I'll sit down and sketch out a bar chart first so I've got a good idea of what's happening with the energies. You use that energy bar chart to give you an energy conservation equation. That's the example I had, was kinetic equals gravitational. And then you can add the formula in and do the maths and solve it.